All right, I'm wanting to show here now, using the iPad, I want to develop how the limit definition of derivative was used to show the shortcut rule for the product, the derivative of the product of two functions, okay? So like this is the statement of it, cap f of x equals, we're defining it as the function that's f of x times g of x, two different functions, okay? We're multiplying them together. The shortcut rule, the shortcut way to say it is, this would have been really clear to say f of x, g of x, but the shortcut way of saying it is that if y equals f times g, then the outcome turns out to be the product rule, which is then y prime equals the derivative of the first times the second plus the first times the derivative of the second, okay? And that's written in more complex terms, and with x's in there, it fills out a little bit. But we're going to use the limit definition of derivative to verify that, okay? So look at this first step here. If the cap f of x equals little f times little g, then the derivative, the first step of that is, notice we got the limit as h goes to 0. The f of x plus h terms means you stick a x plus h into both functions and multiply them together. And then subtract f of x, the original function, which is the f of x times g of x over h. So now let's go to the next step. And this is where mathematically, sometimes we introduce things mathematically that keeps accuracy in place, and yet allows us to do something that it's a legitimate effect that allows things to work in the direction we're hoping it to go. And this is one of those examples. So we've got the limit as h goes to 0. I could have put a smiley face there, but let me just keep it legal for right now. We got f of x plus h times g of x plus h. And now I'm going to subtract and add the same value in here. It's going to help us downstream just a little bit here. So I'm going to put in minus f of x plus h times g of x. And I'm also going to add that in there. Okay, and then I'm going to subtract off f of x, g of x. So I haven't changed anything. I subtracted and added the same value. Mathematically, that's saying it's cool. But now if you notice that if I factor things out in a particular direction, it'll actually transpose, become something that is going to be more meaningful. It'll go in the direction we're hoping to verify. So we've got the limit as h goes to 0. If I factor out that f of x plus h, notice what we get. And this will be looking similar soon. We've got g of x plus h minus g of x. Okay, so notice now, if you multiply that back out, you get this term, and then you multiply this times this, and you get this term. It gives you the same thing back. And then coming back on the other way, notice what we get. If we factor out the g of x, we end up with, so I got a plus here, factor out g of x, I'll put that afterwards. So I've got f of x plus h minus f of x times g of x. Okay, so that factorization comes from that right there. And this is over h. And now the mathematics of it is that we can distribute that h. You know, h can be split into two different fractions. And limit is going to go also with both terms because the limit of a sum is equal to the sum of the limits. So we end up with the limit as h goes to 0 of, notice what's happening here. I'm going to, when we can distribute that limit as h goes to 0 across the board, we end up with this f of x plus h. Now we've got times the limit as h goes to 0 of g of x plus h minus g of x. And what I'll do is I will put that divided by h on that puppy. And that's one product, so that the h goes with that term, the h goes with this term, right? So you multiply that out, and you would get that exact same thing back. Plus now the limit as h goes to 0 of, and again, I'll put the h with this difference, and then multiply it times the limit as h goes to 0 of g of x. All right? And then look what we've got here. And this is the limit definition of, that is g prime. That is g prime. So we end up, so I'm going to do a couple things at once here. As h goes to 0, the h disappears, and we end up with f of x here. Right, plug in 0. And the limit as h goes to 0 of this scenario is actually g prime. And then if you notice that if, again, we've got f prime. This is f prime. And then the limit as h goes to 0, there is no h. So the limit as h goes to 0, it's just g of x. So, and then notice the order of these things. We've got f of x times g prime of x plus f prime of x times g prime of x. Well, notice commutative property means we could switch those. And that means we would end up with f prime of x times g of x plus f of x times g prime of x. And when I talk about the quotient rule, you'll see that this order matters in the quotient rule. In the product rule, you can do it either way. You can switch. Multiplication is commutative, addition is commutative. But when you get to the quotient rule, you got a subtraction problem. And it's not commutative, so it's got to be a specific order. And this order will match. Okay? That is the product rule. Thank you.